All right, we got a train. It's driving down the tracks with a constant, that's a key word there, initial velocity of 20 meters per second. How much time does it take the train to go 1 mile, which in this case I'm telling you is 1,609 meters. So that's pretty important information there, right? There's not a lot of variables showing up, but that word constant will help us out. So when I see a constant initial velocity or just a constant velocity, that tells me that my acceleration is 0. It's not changing. It is the same velocity the entire time. So my initial velocity, v naught, is equal to 20 meters per second. Now, technically, my final velocity is also 20 meters per second, but I really only care about that initial velocity in this case. How much time, so that's what we're looking for, is t. And then we know the displacement, delta x, is 1 mile, which is 1,609 meters. When I look at this, I don't see final velocity, so that tells me that we are going to be using our first kinematic equation. Delta x is equal to v naught t plus 1/2 at squared. Now I can begin to plug in all my information. 1,609 for delta x, initial velocity is 20, t is unknown, plus 1/2, 0 for my constant velocity, and my time of t squared. What's really nice about this is, look at this. 0 times anything in the world, this is in fact just 0. So this whole chunk right there just cancels out, which is really, really nice to see. That leaves me with just this part right over here to solve for. We don't care about that second part. So if I want to get t all by itself, let me go ahead and rewrite this. 1,609 is equal to 20 t. I'm just going to divide by 20 to solve for my final answer. Bust out my calculator here. I have 1,609. I'm going to divide that by 20 seconds. Or I'm sorry, 20 meters per second to get my final velocity of 80, I'm sorry, not velocity, my final time of 80.45 seconds. 80.45, oh my, 80.45 seconds. So that's a little bit more than a minute. Fun fact, it only takes me a little bit more than a minute to run 1 whole mile.